Welcome to Lesson 36, Writing and Solving Proportions. First thing we're going to do is just write in the definition of proportion. And the definition of proportion is an equation that states that two ratios are equal. Go ahead and write that into your notes. And then the next word that we're going to be looking at today is similar. So we're going to be using proportions to show similarity. And similar for shapes means that they have the same shape, but do not have to be the same size. So within two similar shapes, sides and angles correspond. And we'll talk more about that down below when we can look at these two shapes as examples. Okay, the next word that we're going to look at is congruent. Congruent means that corresponding angles in similar shapes are congruent, which is where we use this word. And the word congruent itself means that they have the same measurement. So it's very similar to saying that two things are equal, but we say congruent when we're talking about measurement because we're talking about two different measurements. We can't say that we have 1 cup of juice over here on the right and another cup of juice on the left, and they're equal to each other because they're not the same cup of juice. They're different cups. But they're congruent because they are the same measurement. We show congruency by using the symbol of an equal sign with a little tilde above it. So this is the sign that we use for showing that things are congruent. Got it a little dark there. Okay, the next word we're going to look at before we get started here is scale factor. Scale factor is the ratio of a side length of a figure to the side length of a similar figure. So go ahead and write that into your notes as well. And I'm going to show you a few examples of what I'm talking about. Down at the bottom of the screen there is a similarity statement. PQRS is similar to WXYZ. So that's what we call a similarity statement. So if you want to write that in your notes as well, go ahead and do that. Similarity statement. These two shapes are similar. They have the same shape and they have corresponding sides and angles. We write corresponding angles which are congruent. So corresponding angles are congruent. That means they have the same measure. We're going to write this as, actually I'm going to move on to the next page for this. So again, this is our similarity statement. And the similarity statement shows corresponding angles and sides by the order of which the letters are written in the similarity statement. So if we're looking at angles, we would have angle P is congruent to angle W because they're the first angles in the statement. And then angle Q would be congruent to the next letter, which is angle W. I'm sorry, angle X. What am I talking about here? Let me erase that. Angle X. Okay, and then angle R would be congruent to angle Y, and angle S would be congruent to angle Z. So we're going to use this information to answer the question for letter A about these shapes. Find the measure of angle Q and the measure of angle Z. So let's look at angle Q first, which is up here in this corner. So we know that angle Q is going to be congruent to the measurement of angle X because of our similarity statement here. So we can write in, we know that angle X over here is 60 degrees. So we can fill in 60 degrees in the place of the measurement of angle X, and that will give us the measurement of angle Q because they're similar, so they have they're congruent, so they have the same measurement. So the measurement of angle Q is 60 degrees. And then the next one we're looking for is the measurement of angle Z, which is in this corner. And we know that the measurement of angle Z is congruent to the measurement of angle S because of this similarity statement. So we know that the measurement of angle S, over here is 120. So we can fill in 120 degrees. And we know that that's going to be equal to the measurement of angle Z. So there we go. The next part is about scale factor. So in order to find scale factor, we need to use, if we go back to our definition, scale factor is the ratio of a side length of a figure to the side length of a similar figure. So we're going to use side lengths for this one. So we want to look for two side lengths in these shapes that are on the same side, so on, corresponding sides, and they both have a number because we need two numbers in order to make a scale factor to fill in for our ratio. So I've noticed that this side, SR, has an 8, and its corresponding side, ZY, has a 2. And I know they're corresponding because SR and ZY are in the same order in the similarity statements. So I'm going to write down SR equals 8 over ZY, which equals 2. So that's my scale factors, 8 over 2, which I can reduce to 4 over 1. Okay, and then C is to use that scale factor to find QR and Y, or WZ, So QR, let's find that. That's this side here. So we're going to be looking for A. That side is corresponding to this side that is 3 in the other shape. So we can do A over 3 is going to be equal to our scale factor of 4 over 1. And then we can cross multiply, and we have 12 equals 1A, which means A equals 12. So that is QR is going to be equal to 12. Okay, and then the other part is to find WZ. And WZ is represented by B here, and it's corresponding to PS, which is 12. So if I have WZ over PS, WZ is equal to B in the shape, and PS is equal to 12. And I've actually flipped these around, so I put the smaller shape on the top. So in my scale factor, I'm going to put the smaller number on the top. So I'm going to use 1 over 4 and cross cancel. So I'm running out of room here. So I would have 12 times 1, which is 12, is equal to 4B. So then I would divide by 4 on both sides, and I would have B equals 3. So the measurement of WZ is equal to 3. There's that answer. Okay, moving on to another example here. This is another example that you proportion in a real life situation. If you have a basketball player that casts a 5-foot long shadow, so if we draw a triangle here, we have our b-ball player here. This is how tall he is, and his shadow is 5 feet long. And that makes a triangle. And then we also have a woman who is 5'5" tall and has a shadow of 4 feet. And it says that these two triangles are similar. So they must be standing in right next to each other in the sun, where the sun's shining down at them at the same angle. So how tall is the basketball player? So we can use a similarity statement for this. We know that the shadows are going to be corresponding. So we have 4/5 for the shadows is going to be equal to these other corresponding angles of 5.5 over x, because that's the one we're looking for. So we would multiply, cross multiply. 5.5 times 5 is 27.5, and that will be equal to 4 times x. Then we divide by 4, and x equals 6.875 feet. So that's how tall our basketball player is. Okay, moving on, we have a couple more vocabulary words, and I'm going to write in the definitions. I'm going to pause while I do this so I can save time. Okay, you will want to pause the video so that you can write in these definitions on your notes. But a scale drawing is a drawing that reduces or enlarges the dimensions of an object by a constant factor. So an example might be a map or a blueprint, or sometimes we put things on a copy machine and blow them up, as we usually say, which means to make them bigger or enlarge them. A scale is the ratio showing the relationship between a scale drawing or model and the actual object. So let's look at an example. In a scale drawing, a kite is designed so that the length of the tail is 9 centimeters. So if we have a kite, the length of the tail is 9 centimeters in the drawing. If the scale factor is 1 centimeter to 10 centimeters, what is the length of the actual kite? So we'll set this equal to another ratio. So this here is the scale that tells us how they're related. So we fill in what we know. The 9 centimeters is going to go on the top because we know that this is the drawing, which is smaller than the actual. And then we need to find the missing number there. So if we cross multiply, we'd have x times 1, which is x, equals 9 times 10, which is 90 centimeters. So the actual length of the tail of the kite would be 90 centimeters. Okay, at the top of your notes on the 3rd page, there's a box that just explains how scale factors are related as far as perimeter with area and volume. Obviously, area is squared, so it's going to be, if the perimeter is a over b, the ratio of the areas is going to be a squared over b squared. And volume is cubed, so it's going to be a cubed over b cubed. So we're going to do last couple examples here. We have a dartboard with concentric circles. The radius of the smallest circle is 1 inch, and with each additional circle it goes up by 1. So at the bottom here, what is the ratio of the radius of the innermost circle to the radius of the outermost circle? So we're going to start with the innermost is 1, it tells us. And the outermost, we'd have to count up here. There are 1, 2, 3, 4, 5 circles, so that's 5. So the ratio is 1 to 5. The ratio of the circumference is equal to 2 pi r. So the two inner circles, maybe I should separate these here. The two inner circles would be 2 times pi times 2, because if we put 2 of these radiuses together, it would be 2. And then the outermost, I'm going to go over 15 minutes here, so you'll have to be watching this on YouTube, would be 2 times pi, and then the radius would be 5, because the outermost is 5 circles deep. So when we have something like this, we have 2 times pi times 2, 2 times pi times 5. Since it's all multiplication, and these are factors, we can cancel out the factors that are the same. 2 divided by 2 is 1. Pi divided by pi is 1. So we're left with 2/5. And that's our ratio. So the last one, the ratio of the area now. So area is pi r squared for a circle. So we're looking at the innermost again to the outermost again, just like we did in the first one. But this time we're filling in area. So the area of the innermost, the radius is 1, so it's going to be pi times 1 squared. And on the bottom we're going to have pi times 5 squared, because we know the radius of the outermost circle is 5 deep. So again, we can cancel out the pi's, because pi divided by pi is 1. And on the top we have 1 squared, which is 1, and on the bottom we have 5 squared, which is 25. So our ratio is 1/25. And that is the end of our lesson. Thank you for watching and taking notes.